Hey, hello everyone, and welcome to today's webinar From Imagery to Insights, using dashboards for smarter property condition assessments. I'm Jennifer Getz, the editorial director of Facility Executive Magazine, and this webinar is presented by ZiteView. Before we get started, I'll cover a few housekeeping items. There will be a question and answer segment at the end of the presentation today. Please find the question box in the dashboard at the bottom of your screen. This is where you can submit questions for our speaker today. If at any time you experience a technical difficulty, please send us a message via that question section and someone on our team will answer you privately. Now, without further ado, I'm happy to introduce your speaker for today. Jonathan Lewowski, Director of AI/ML with ZiteView, is an experienced AI leader with extensive experience building and guiding high-performing machine learning teams to create scalable, real-world solutions. He excels at bridging technological innovation with business objectives, collaborating with cross-functional partners, and driving initiatives that deliver measurable impact. With a proven track record in both startup and enterprise environments, Jonathan focuses on strategic alignment of AI solutions, transparent communication of AI capabilities, and cultivating an environment where teams can innovate and grow. So Jonathan, thank you so much for joining us today.
Thank you, everyone. Today, I'm going to talk to you about how we use AI at ZiteView across our properties vertical, along with hopefully equipping everyone here with a toolkit that they can use when validating AI vendors to know if they're actually real AI technologies that actually solve real problems, or if they're just a facade and are just hiding behind AI, but really don't provide much benefit to the end user. So those are the two goals for today. So I'll dig in. Who are we at ZiteView? So at ZiteView, we operate across 5 main verticals: wind, solar, properties, telecom, and utilities. For each of these verticals, we cover from pre-construction to construction, commissioning, operation, and acquisitions. We help with all of these. Today, we're going to mainly focus on number 4 here, operation and maintenance of properties. For each of these verticals, we have AI technologies and tools to help in each of these sections. But like I said, we're going to be focusing on operation and maintenance today. So what are the major challenges that property managers face today? The first one is high interest rate. So with these interest rates increasing, it makes the margin and profit for our properties much smaller. So we need to be able to get smarter on how we can actually manage these facilities to make sure that we can get some of that interest back. Along with that, we have budgeting seasons, which we know that these seasons are very stressful. And when we need to be able to budget for the maintenance and operations of all our facilities, it's important that we are able to prioritize the facilities that have the most issues and not just picking random buildings or because of some timeline. The third issue is incomplete data. Typically, property managers today will only have data for some of their properties, or if they do have all their properties, it's mixed from different time periods, different locations, or different amounts of details, which makes it really hard for you to truly understand which properties need the most attention. And the last one is shortage of skilled labor. Even if you do have the budget and you do have the data to be able to know which properties have the amount of damage that requires maintenance, typically you only have so much labor that you can actually send out to these properties. So it's important that you're able to optimize where you send your labor to make sure you're repairing or fixing the properties that have the most amount of damage. So in order to solve that problem, we've built this dashboard. I'll quickly highlight some of the key features here, and then I'll go into how do we actually build this dashboard. So at a very high level, across your entire portfolio of sites, we can actually collect different scores for different parts of your property. For example, in the upper left corner, we have our roof condition score. And you can see that we have a score from 100 to 0, 0 being really bad condition, 100 being really good condition. So you can actually go through all your sites in your portfolio and be able to know what is the condition of each of these properties and which one is the worst condition, which one's the best condition. Similarly, we have this for roof equipment. So what is the condition of all the different equipment on your roof? And we can do this for your pavement. We can do this for vegetation all across your properties so that you know from a score of 0 to 100, which ones are the best conditions, which ones are the worst conditions, and why. And then you can actually dig deeper, which I'll show in the next slides, on what is causing these conditions to be poor. So the big question here is, how do we actually generate this data? So we actually have a drone network of pilots, or you can fly your own drones as well that enable you to basically fly your property with thermal and RGB imagery. All that data is collected via our AutoFly app, which enables us to automatically fly your property. That then gets uploaded into our cloud platform where we can collect the data, run QA on it to make sure all the imagery fits our quality needs for exposure, blur, GSD, things like that. And then we have a whole bunch of AI-powered tools that will go and try to automatically detect different things on your property, such as what components are available, what damage is on the property, how much vegetation do you have, etc. But as always, AI is not perfect. So then we have a round of human QA that verifies that all the AI predictions are correct, along with if there's any AI predictions that were not made, that were missed by the AI, our humans will also fix that. And then lastly, all that gets uploaded into our platform, which is used to drive the actual condition scores that you have. And for each of those condition scores, you can actually click into the property and see what actual issues caused the condition scores to be low. And then with that, you can then know how should you prioritize your properties through portfolio management, predictive analytics, etc. So you can know where to send your crews to make the best maintenance decisions. So how can AI help with this? You could do this all manually with humans, but that's very time consuming and typically can also have quality issues. So I'll highlight the 5 main sections here on how we use AI to make this better. So first, navigation and flight. Before AI, what you'd have to do is send out a crew of people to actually go to the property, walk the property, take pictures of everything, note all the different issues, etc., which is very time consuming and tedious and typically can result in some quality issues. The human might make mistakes and miss things. But and then going into quality checks, once the technician has that, they have to manually check for quality mistakes. So you might have a secondary person reviewing everything that the technician did to make sure that it's consistently collected. There's no issues, no missed data. And if there is, then you have to report that back to the technician. The technician has to redo their walk, which again adds more time. Once you have all this, if you require measurements of your property, again, you have to send a human out to actually measure your property to make sure that you have all the measurements, you have the proper square footage of your roof, proper square footage of pavement, etc., which again is time consuming and can have inconsistencies. Once you have all this data and images of everything on your property, you then need humans to manually count the different things on your property. So if you want to know how many HVAC units you have to have somebody count those. If you want to know how many RTUs you have to count those, skylights, how many parking spots, anything on your property. If you want to have somebody do that, that has to be all done manually, which this is a common theme, takes a very long time and can lead to inconsistencies. Lastly, if there is any inconsistencies in your data, you have to go and train your analysts or technicians to address those problems. So in the future, that doesn't happen again. But again, that if you hire new people, you have to train them. If they make the mistakes again, you have to retrain them. And that training process and feedback loop, again, is very time consuming. However, after AI, we actually have semi-autonomous drones that can capture all the images. What that means is every time you fly your property, the same images will be captured. We know the quality will be good because the is automatic and autonomous, and we can make sure it's always consistent. And also, this is much faster. Instead of it taking 12 hours to walk the property, this can just be done in a matter of an hour or so. Again, we have quality checks that sit on our drones for blurriness, coverage checking, orientation, exposure checking, a whole bunch of different quality checks that are on the drone itself. So as the drone is capturing these images, if there is any kind of quality issue, we will know immediately. We can address it while the pilot's still on site, and then we can resume the flight and fix it immediately. And then because all this imagery is collected autonomously and it's consistent, we can also use automation to consistently build out digital twins of your property, which then leads to automatic measurements of your property, which is a lot more consistent and a lot more accurate than having a human do this manually every single time. Then moving on to the detections. So we have AI models that can detect all different kinds of things on your property. And this is done automatically within seconds. And then with that, you have all these counts. Again, AI is not perfect, so we will do a human review. But that human review plus AI is significantly faster than just doing it purely from a manual setting. And then lastly, we have a feedback loop automatically built into our systems that as we collect new data from all our customers, and if the AI makes mistakes and the human fixes it, all that mistakes are fed back into our AI models. So over time, the AI models get better and better and better, making things faster and more efficient. So digging a little bit deeper into the navigation, again, like I mentioned in the past, we have automatic flight collection where our drones using our auto flight will automatically fly your property, collect all the images that are required, and it'll have high quality and is consistent, which is important because with consistent data, we can all the downstream tasks that I mentioned will be much better quality, and it's much faster and safer than having humans do this manually. The quality checks, like I mentioned, we have a bunch of different models that run on the drone itself. One good example is exposure. You can see if we're collecting underexposed or overexposed imagery, it makes it hard to tell what's in the images. However, we have these models that tell us on the edge if it actually is properly exposed. And if it isn't, we can address that while on site. And then once we know we have good quality data, then we know the AI models will work well downstream for detecting the different issues or different components on a roof. For measurements, we have what we call our rooftop measurements model, which given an image of a property, we can actually measure all the different roof slopes, which again is directly connected to cost estimation and planning. And because this is done automatically and with AI, we can ensure that the quality is really good and it works really fast compared to doing it manually. For detections, we have AI models here that can detect various things from components on a roof, such as HVAC units, pipes, gutters, to things on your pavement, such as parking spots, handicap spots, to vegetation in your parking lot, such as trees and shrubs. And again, this is a combination of AI plus human review. But we can also do damage detection, such as like membrane damage, water ponding, vegetation that's overgrown. And those are all things that are important to know when prioritizing your budgets. And the feedback loop here is probably the most important thing in this cycle because AI models are never perfect. So starting at the top, you can see a field technician will get some AI detections and realize there's mistakes. The field technician will fix those mistakes. Those mistakes are then added to our training data, which then we retrigger our models to retrain. Once the models are retrained, we can evaluate those models to know if it got better and to ensure that it didn't get worse on the previous detections. Once we validate the new model is working better, we can deploy that back into production. And then any future use of this model will be better. And this cycle is done over and over and over again. So our models just get better over time. One, they get better, but two, if new things come into the field, like say a new HVAC unit style comes out that the model has never seen before and it does really bad, then it'll automatically learn to start detecting those and will be able to do a better job in the future. So now I'm going to talk about the red flags for fake AI. So in AI, there's a lot of fake or people who oversell AI, which leads to a bunch of distrust in the field. So I'm going to try to give everyone some red flags for fake AI and to discuss the green flags on the alternative side. So one thing that you should be asking is what data set these models were trained on and what is the diversity. If a company that you go and talk to that claims to have AI does not discuss the size of their data set or the diversity of their data set, that's a big red flag. The data set is the number one thing to make a good AI model. On the flip side is if they are willing to say, hey, our AI models was trained on a wide variety of properties and environments, and we made sure that there's a lot of variety, that's a green flag. They should be willing to tell you what data they use, how much of it, what was the variations that they use in order to claim that their models are good. They should also be willing to discuss their data labeling process. If they don't want to discuss their data labeling process, that's another red flag. On the flip side, they should be willing to discuss that. They should be saying, hey, we actually reviewed all our images, we reviewed the annotations, we use a data labeling team of humans and experts to make sure our data is of the best quality possible. Another red flag is when discussing model architecture, they use these big AI buzzwords like ResNet 50 or Inception or YOLO or UNet, these big buzzwords, but they don't clearly explain why or they're using those specific models. On the flip side, they should be talking about why they chose specific models, not just using buzzwords. And each model has their pros and cons, and they should be willing to discuss why they chose those. Continuous learning or active learning is another way that you would hear it, is if they are not willing to discuss how their system is getting improved upon over time, that's a big red flag. Every AI model needs this. Just because I train a model and it works really well today doesn't mean that in 6 months that same model will work as good as it did when you first deployed it. So on the other side, they should be open and willing to discuss that they are actively working on or have models that are continuously learning by integrating new data into the model and retraining on some period of time. The last one, this is probably very common, is that a lot of these AI companies will claim that their AI models are 99% accurate and they have these amazing metrics, but that's usually a red flag. On the other side of the coin, I would rather see what are the performance metrics on actual business metrics, like how much cost are we saving our customers, or what is the time we're saving, things that are actually measurable versus just saying, oh, my model is 99% accurate. So again, the theme of what questions should you ask or what things should you be looking for when evaluating AI vendors, I'm going to give you some questions that you should ask. The first one is how large and diverse was your training data set and what edge cases or outliers does it cover? A good answer would be my model was trained on X different geographies across Y different properties, across multiple years, multiple seasons. It had a various sensors, various drones, various pilots. And also we made sure that we covered a lot of edge cases like trees overhanging our property. That's a very good answer. And if they're not willing to discuss that in detail, that should be a red flag. The next question is around data and labeling. How was the data gathered? How was it labeled? And what QC processes did you put in place to make sure it was labeled process or properly? A good answer would be we collected from our production and test pilots across customer and test sites, along with targeting edge cases to make sure that we have this. Also, we have a 3-stage labeling process with 2 rounds of QA to ensure this has good accuracy. This is a very good answer because it discusses how it was collected, but also how it was labeled for AI, because it's a cliche saying, but garbage in equals garbage out, and it's very true for AI. If the data you're using to train your AI model is not labeled properly and of good accuracy, the model's not going to be able to learn properly. So it's very important that you have very good, high quality labeled data for your models. Model architecture, a good question to be what types of models form the backbone of your solution and why were these chosen for your specific use case? So a good example would be we use object detection with multiple boundaries and segmentation models for ensuring condition assessment, ensuring accuracy for each use case. And even better, they would be like, we chose segmentation because we require a high level of measurement accuracy, which segmentation helps with. Or on maybe a detection side would be, we don't really require that high level of measurement accuracy, but we do care somewhat about our rough location, and that's why we chose object detection. You should be able to get what type of model and why they chose it out of them. None of that should be proprietary. It's very generic across the board. For continuous learning, I would ask, how does your system adapt as new data comes in? And how do you confirm it's actually learning and improving? A good answer would be new images are regularly fed into retraining, incorporating customer annotations, along with having strict QC to ensure accurate and unbiased model updates. This is a good answer because they're taking new data from production and retraining their models, but they're not just blindly trusting that the answers are correct. They're checking the customer annotations along with QCing it to make sure that it's labeled properly. And then they're retraining the model and making sure that the model updates are not biased. And then performance metrics, beyond accuracy, can you dive deeper into metrics that you track to prove real world effectiveness? So there are measures like F1 score, precision, recall, IOU. Those are all academic AI metrics that they do have their value, but ultimately what matters to the end customer is the business impact. So I would like an answer that focuses more on how much time are you saving your customers? What cost reductions are you benefiting the customers that actually are business metrics rather than just some highly theoretical AI metric that truly, unless you're deep in AI, you won't really understand what that means. Some other things to consider when investing in an AI solution is scalability. So you would want to make sure that this AI company can handle a very large portfolio size so that you can make sure that they're able to adapt to a wide range of portfolios and different data types. Interoperability, making sure that their AI solution can integrate into existing asset management software so that you can use it easily. Portfolio size. So like I mentioned, AI benefits from scale. So you want to make sure that the AI company has a pretty good sized portfolio so their AI model's robust and that it can also work on small portfolios all the way to large, very complex portfolios. Commitment to R&D. AI is a very, very fast moving field. So you need to make sure that AI company is very committed to R&D because if not, in 6 months, AI is going to get better. In a year, it's going to get even better. So if they're just using technology that's from today and they're not committed to R&D, their AI models are going to fall behind compared to their competitors. And number one thing is their data quality, making sure that the data that they are using into their models is of the highest quality. If you don't have good quality going into the AI model is not going to produce good answers. So here are some emerging trends in AI property management. So this is some things that you'd probably want to ask an AI company if you're interested in AI for property management. One is predictive analytics. So how are you going to use AI to actually forecast into the future and predict failures before they actually arise? So that's something that we're actively doing R&D on. The other one is sensor fusion. All that means is if you have sensors from a variety of sources, can you combine that together in order to make better, more accurate decisions for both current anomalies, but also the predictive analytics? And the last one is multimodal AI. So this is how can you leverage different modalities such as LiDAR, thermal, RGB images into a single AI system, again, to get better AI predictions and better predictive analytics for your customers. And these are three things we are actively doing research in right now in order to make sure that we stay on top of the trends of AI. So how do we win with visual AI? To summarize, by using AI, we can optimize cost and efficiency. The main way is by reducing operational costs by automating these inspections. Having humans do this manually for all your properties multiple times a year is very expensive and probably not very likely to happen. But also, we want to make sure that all of this data is collected consistently across all your sites so that you can make sure that you are addressing labor shortages and rising costs by proactively maintaining your properties. So going into the next point is proactive risk and maintenance. So hopefully, once we are able to do predictive maintenance, we would like to be able to identify as many failures before it actually happens as possible so that you can send your crews out to address these situations before the actual failure happens. And then smarter budgeting and resource allocation. Because we provide consistent property scoring across all your properties, you'll be able to allocate your resources much more efficiently. And then going forward, scalable and adaptable portfolio management. Again, the larger your portfolio gets, the more complicated this cost optimization and maintenance effort gets. So being able to make sure that you can scale your maintenance across all your portfolio is very important. And lastly, being able to connect with an asset management platform to actually make sure that these maintenance are actually getting done is very important. So that's the end of the webinar. I would like to hear from you. What challenges are top of mind for you, and what are some unique problems that you're currently facing that AI potentially could help us solve? Now,
John,
open questions.
yeah, Jonathan, you did a great job. Thank you so much for sharing your expertise with our audience. And I also want to thank our audience for sending in some questions for you to address. So, Jonathan, to get started, our first question here is AI can flag issues, but humans, ultimately still need to respond. So, how should property teams balance automation and with hands-on expertise to ensure timely, accurate repairs?
Yes, so as AI models get better and better, the amount of human review will go down, and it should just become a very quick confirmation like AI is correct, because ultimately we want the humans to make the final decision. We shouldn't just trust, at least with the current technology, you should never be just trusting AI blindly. Once you have all those decisions like approved or denied from the AI prediction by a human, that will be used to build out the scores that I mentioned in the dashboard. Let me go all the way back. The dashboard here.
Mhm.
Once humans have approved and denied all the underlying anomalies that were detected by our AI model, these you can trust. And once you have these, you should be able to know which properties are in the best condition, which ones are in the worst condition. That doesn't necessarily mean that you should trust, oh, send your crew out to the one with the worst condition or the one with the next worst condition and go that way. But that should be where you should be starting the conversation with your maintenance teams to say, here are our 10 top 10% properties with the most anomalies. How should we be budgeting this? And
Mhm.
all these scores that we have on our platform are we can go and adjust based on your needs. So if you say, hey, water ponding is my most severe anomaly, or membrane damage is more severe, or vegetation overgrowth is more severe, we have mechanisms in our platform that you can adjust the scoring based on your own personal needs so that you can get better condition scores for your properties that you can trust more. And then ultimately, after you review each of these properties, it's up to you to make the decision which one should you send crews out to for maintenance.
Mhm. Perfect. Perfect. Another question we have here for you is, so for operators managing diverse assets, so commercial, multifamily, industrial, really, how does visual AI adapt across different property types?
Yep, so that comes down to the data that you have. So ultimately, you need to make sure that your data is diverse and encounters as many variations as you can. So if you're going to have a model that's going to operate from in just Texas, then you really just need models that are data that's from Texas. But if you
Mhm.
want a model that works across the entire US, well, now you need to make sure that you have data that's collected from all across the US, all across every state. And now, if you want to go worldwide, then you need to make sure that you have data across worldwide. And then if you want to say, oh, I only want to target big commercial buildings, again, oh, we need data for that. But if you want to target small, medium, large, it really comes down to a data problem. And that's why, if you notice, a lot of the question or the red flags that I had or a question to ask was around the data. Because if
Mhm.
you know you have a specific type of property and they don't have data of that property, the AI model is going to struggle and they're going to need to collect that data and retrain on that type of data.
That makes sense. Yeah. Well, another question we have here. Somebody said, well done regarding AI and outdoors. But I think they want to know more about AI and indoors. And that was their question.
Yeah, that's a good question. We currently do not do anything interior of properties. So that's the short answer, but all the same Q&A that I said, the red flags, green flags, questions asked, would 100% apply to indoor AI. So if you're evaluating an AI company that does interior inspections, definitely ask those exact same questions to them as well.
Mhm. Perfect. Okay, so another question here we have is, um, can AI prioritize property management issues based on severity, cost, or safety risk?
Yes. So we have a cost estimation tool built into our platform, so you can get an idea of how much it would cost to estimate each of the properties or to repair each of the properties we have. Along with that, like I said, we have a property scoring, like I'm showing right now on the screen, that you can adjust based on your own preferences and priorities. So all these scores are fully customizable where you can put more weight on different anomaly types, different component types, different parts of your properties so that you can ultimately drive how you decide what is the most important properties to address versus least important. But ultimately, the underlying data is really what drives everything, which is what anomalies do I have on my properties? What components do I have on my properties? And after that, the dashboard itself can be built on top of that.
Mhm. Perfect. Perfect. I think we are just about at time here, but Jonathan, I want to thank you so much. And I want to also thank our attendees for sending in questions. If we weren't able to address anything, I know, Jonathan, you had your email at the end of the presentation. Maybe just we can go back to that very quickly. Um, but I want to thank you for this informative discussion today. And of course, to ZiteView for sponsoring this webinar. And of course, to our audience for attending. A recording from today's session will be made available on our magazine's website, facilityexecutive.com, and on ZiteView's website at ziteview.com. So everyone, thank you so much for attending, and I hope you have a wonderful afternoon.
Thanks, everyone. Definitely, if you have any questions, feel free to email me.